I'm just going to introduce our next speaker, and it's Steve Hamley, who is a PhD candidate who actually is at Deakin University, is that right? Good, okay, I got that right. His PhD is investigating the metabolic and physiological responses to a meal in people who are healthy, who are either pre-diabetic or have type 2 diabetes, and whether these responses are altered. And his talk today specifically discusses saturated fat. So thank you, Steve.
Can you hear me? Yeah. So as you can see, this presentation is not really related to the PhD, it's just an interest I've had recently. So I think this topic, the relationship between saturated fat and coronary heart disease, is quite an interesting and informative one for a few reasons. Firstly, it's actually quite an important part of conventional dietary advice. So we're told to cut the fat from our meat, to have low-fat dairy, replace butter with margarine, often leading to an emphasis on plant foods over animal foods. It's also quite controversial. So in the media, butter was bad, and then it's good again, and then it's bad. And the media loves this because they love controversy, but this only really serves to confuse the public, who may ultimately just opt out of engaging in nutrition science altogether. And thirdly, I think that the story between saturated fat and coronary heart disease can give us some insight into some of the issues in nutrition science, and I hope that these are the real takeaway messages from today. So ultimately, the reason that we're given this advice to reduce our intake of saturated fat is basically this, that it increases LDL cholesterol, the so-called bad cholesterol, and that LDL cholesterol is associated with an increased risk of coronary heart disease, which is what causes angina and heart attacks. The assumption is often made that therefore saturated fat will increase the risk of coronary heart disease, but that's not necessarily a valid assumption to make. But in addition, saturated fat not only increases LDL cholesterol, but also increases HDL cholesterol, and as a result, does not increase the ratio between total cholesterol to HDL, which is perhaps the most predictive measure of blood lipids for coronary heart disease. So you could make the hypothesis then that saturated fat will not increase the risk of coronary heart disease because it does not increase the total to HDL ratio. This is actually consistent with now 7 meta-analyses of observational studies that have found that people who eat more saturated fat tend not to have a higher incidence of coronary heart disease. The evidence from clinical trials, randomized controlled trials, is a bit more limited. So saturated fat has been reduced as part of low-fat diet trials. So one control group, one group on a low-fat diet, and these tend not to be effective. It's also been reduced as part of Mediterranean diet trials. These are often effective, but are inappropriate to test the effect of saturated fat because so many dietary variables are being manipulated, like whole plant foods, for instance. It's also been reduced as part of trials where saturated fat has been compared with polyunsaturated fat, so high polyunsaturated fat diets. And this is really what people like the Harvard School of Public Health are recommending, and that's because on the surface at least there's some good evidence that could suggest that polyunsaturated fat will be protective. So polyunsaturated fat reduces the total to HDL ratio. It's inversely associated with coronary heart disease in some observational studies. So that means high polyunsaturated fat intake, less risk. And in some of those trials that I just mentioned, the polyunsaturated fat group had a lower incidence of coronary heart disease. And so I'm just going to talk about these for a minute. So this figure is called a forest plot, and it's the nuts and bolts of a type of study called a meta-analysis. And a meta-analysis is a type of study that pulls together the results of several similar studies in order to kind of pull the effects together and arrive at some sort of average. And this column lists the trials that have replaced saturated fat with polyunsaturated fat. These columns include some of the results from the studies, so how many people had coronary events, how many people in each group. This is a bit of a representation of the risk in each study. So studies with a lower incidence of coronary events in the polyunsaturated fat group have the blue square left of the vertical line, and those studies with a lower incidence of coronary events in the saturated fat group have a blue square to the right of the vertical line. And it should be quite clear how easy it can be to simply just pick, one or two outliers to support your pet theory. And I mean, this also plays into the hands of the media, who will often report individual studies rather than a whole meta-analysis in itself. And if you just go down the list, no effect, good, maybe good, no effect, bad a bit later on, it can be quite confusing. And so, just regarding, selection bias and some of these issues, this study often gets used as an example that polyunsaturated fats are protective when just citing one or two studies, while this one often gets used as evidence that polyunsaturated fats are harmful. But of course, both of those studies are outliers and don't really represent the true average. And that is, when just pulling these results together, it suggests that polyunsaturated fat may reduce the risk by 13%. However, this is not significant. P equals 0.19, so there's a 19% probability that result is due to chance. More interestingly though, as I alluded to earlier, these studies produce very different results. And this can be measured with something called an I-square test, which measures heterogeneity, or just a fancy way of saying how different these studies are from one another. And not surprisingly, and high heterogeneity is I-squared above 50%. And so not surprisingly, these studies have quite high heterogeneity, 60%, and this indicates that perhaps there are differences between the studies that we need to consider. Perhaps they all didn't do exactly the same thing. So I had a look at these trials, and I learned quite quickly that the intake of trans fats was likely to be almost always higher in the saturated fat group, except for one study, and this was the second outlier that gets used to support the idea that polyunsaturated fats are harmful. It's hard to know whether it is, you may have heard of this study, the Sydney Diet Heart Study. It's hard to know whether trans fats were higher or lower in the saturated fat group, but for the sake of simplicity, and I've just sort of omitted it later. What I've got here is just some of the dietary information that have been provided by the trials, or direct measurements of trans fat intake where appropriate. And so, hydrogenated shortenings or pastries are often restricted in the polyunsaturated fat group. And one thing you've got to consider when assessing these trials is that all of them were conducted between 1958 and 1992. And this is before the knowledge of the harms of trans fats was widespread, which really only happened in the late 90s and early 2000s. And the investigators of these trials, they really wanted a diet just to lower cholesterol. And at the time, they knew trans fats, like saturated fats, increased total cholesterol. So trans fats, like saturated fats, were restricted in the polyunsaturated fat group. In particular, I've bolded and underlined 3 studies in particular where the trans fat intake in the saturated fat group was likely to be much, much higher than the polyunsaturated fat group. But there were some other confounding variables in these trials, and I'm not really going to let the investigators off the hook for these. So one study was conducted in a mental hospital with a lot of patients. Yeah, mental hospitals are used a lot in these days. And there were a lot of patients with schizophrenia, and there was a much higher, well, slightly higher use of an antipsychotic medication that was later found to be toxic to the heart. So it increased the risk of sudden death due to coronary heart disease by about 4 to 5 times, and tended to cause ECG anomalies, which was the measure of coronary events in this study. Also, participants were not randomized. They were just randomized by hospital and not individually. By the way, this is the study that often gets used as a good example that polyunsaturated fats are protective. Another example, vitamin E was much lower in the saturated fat group in this study, which is 9.4 times lower, and only met 16% of the current RDA. I did some calculations based on the average vitamin E intakes of that period and the calorie intake in the control or saturated fat group, and I would have expected a vitamin E intake of about 9 to 10 milligrams, so I have no idea what happened here. The last 2 studies, quite similar to the Mediterranean diet trials, had a lot of other dietary differences. The polyunsaturated fat group were advised to increase whole plant foods, have fish, weight loss advice, decrease sugar and processed foods, whatever. So quite clearly inappropriate. And I guess this brings us to the reason that we do randomized controlled trials in the first place, and that is to have participant groups that are approximately the same, and this is where randomization comes in. And then, of course, to put them through almost the exact same experimental process. So just replacing, in this case, just replacing saturated fat with polyunsaturated fat, nothing else. And only that way can we be sure that any difference between the groups is due to the thing being tested, in this case, saturated fat and polyunsaturated fat, and not due to something else, like trans fats, vitamin E, or other dietary factors. And so in this respect, I've considered some of the trials to be not really very well controlled. And these include the 4 that I mentioned earlier, as well as the others that are likely much higher, have much higher trans fat intake in the saturated fat group. And then I redid the meta-analysis, classifying 4 trials as adequately controlled. These are the ones that best represent a comparison of replacing saturated fat with polyunsaturated fat, and then the others that are inadequately controlled. And as I mentioned earlier, I just omitted the Sydney Diet Heart study, just for simplicity. As you can see, the overall effect now for these adequately controlled trials, pretty much nothing. A risk ratio of 1 essentially means that coronary events in the saturated fat and the polyunsaturated fat groups is the same. However, in the inadequately controlled trials, the risk ratio is quite huge, 0.64, and this would indicate that the original effect that we saw, the 0.87, is entirely mediated by these inadequately controlled trials, and therefore probably due to the vitamin E, the trans fats, the multifactorial diet interventions, and not due to the saturated fat and polyunsaturated fat. And this is just to say that the difference between the 2 subgroups is significant, perhaps giving my categorization some validity. And this is an interesting result because it is somewhat consistent with what we would have expected from the effect on cholesterol and the effects on some observational studies. We would have expected that polyunsaturated fat would have protected against coronary heart disease. But this wasn't the case in clinical trials. And why is this? One thing to consider is that this table is the NMHRC's hierarchy of evidence, or the National Medical Health and Research Council. And what I've done is a systematic review and meta-analysis of randomized controlled trials, which is at the top of the pyramid, or in the table, indicating the highest evidence base. Observational studies, on the other hand, are probably about the middle. So why are they lower? Well, it's because they're not randomized. People who eat, say, more saturated fat, for instance, also differ in ways from those who eat less. So people who eat more saturated fat tend to exercise less, more likely to smoke, worse diet quality, that sort of thing. There's an attempt in observational studies to adjust for confounding variables. Sometimes this seems to work, other times it doesn't. I want to give you a bit of this adjustment in action, because perhaps some people may not have seen this happen. So I actually lied to you a bit earlier. People who eat more saturated fat get more coronary heart disease in this age-adjusted model. However, this is due to all those confounding variables: the exercise, the smoking, the other dietary factors. When these are adjusted for, these highly significant relationships become nothing. However, it's important to recognize that this doesn't always sufficiently work. And hormone replacement therapy is a good cautionary tale of this. So what happened here is that some observational studies were conducted, and they found that postmenopausal women taking hormone replacement therapy had a lower incidence of coronary heart disease. When they did the clinical trials, they found this wasn't the case. And so they relooked at the observational studies, and they found that the women taking hormone replacement therapy tended to be more health conscious, more likely to exercise, less likely to smoke, better diet, that sort of thing. So that was likely behind the good relationship in observational studies and so it didn't translate into the clinical trials. If you recall, things like mechanisms and risk factors, such as cholesterol, weren't even included in the hierarchy of evidence. There might be a lot of reasons for this, but I would suggest that relying on these ignores other potential factors. Biology is extremely complex, but we like to distill it down to a nice, simple, linear system. So we replace saturated fat with polyunsaturated fat, we reduce the total to HDL ratio, and we reduce coronary heart disease. It's really simple, nice, elegant. But unfortunately, things in biology aren't like that. I would imagine that replacing saturated fat with polyunsaturated fat probably has hundreds of effects. And it's the combination of all these effects together that produced the absence of really any effect for coronary heart disease. And so, for instance, just speculating, if we were to assume that the reduction in the total to HDL ratio was protective, well, perhaps something to offset that might have been the fact that polyunsaturated fats are quite chemically unstable, and coronary heart disease is essentially a disease of lipid and lipoprotein oxidation. So I mentioned a cautionary tale for observational studies. I think the story with carnitine, the recent story with carnitine, is a good cautionary tale for mechanisms. So what happened recently is that a bunch of researchers found that carnitine, which is a nutrient found in red meat, increased a substance in the bloodstream called TMAO, and that TMAO is associated with coronary heart disease. The media, of course, leapt to this conclusion, and people now were proclaiming, aha, now we know why red meat is bad for us. Of course, no clinical trial has been done to test whether red meat actually causes coronary heart disease, but we will ignore that. However, the ironic thing with this is that when randomized controlled trials have looked at carnitine supplementation, they tend to find that it actually reduces coronary heart disease. And again, this goes back to various things having lots of effects. Carnitine increases TMAO. Let's assume that is bad for us. But carnitine is also a beneficial nutrient. It's an antioxidant, supports mitochondrial health, takes lipids where they need to be, that sort of thing. So you can't really just leap to a conclusion based on just one mechanism alone. And I spent a lot of time discussing nutrients, saturated fat, polyunsaturated fat, but we eat food. I'd rather discuss food, and that's because also of some of the difficulty in generalizing the effects of a nutrient to a food rich in a nutrient. So for instance, let's assume that carnitine does reduce coronary heart disease. Does that mean red meat reduces coronary heart disease? Well, no, we can't make that assumption, because red meat has lots of other compounds in it, some of which might be good, some of which might be bad, some of which might have no effect whatsoever. I think this is already pretty well understood with carbohydrates. So, with carbohydrate-rich foods, we have, whole plant foods, fruit, vegetables, grains, legumes, refined carbohydrates, and I can't imagine there will be a person in the room here who would say that they have the same health effects simply because they're all rich in carbohydrate. Probably not. But this conversation hasn't yet really happened with, say, fats and protein to the same degree. And there are lots of different ways to, say, reduce saturated fat, some of which are by reducing whole plant foods, and some of which are by reducing processed foods. And some of these are just examples from the trials I was talking about earlier. Again, do these have the same health effects? Probably not. In addition, there could be some risks of nutrient demonization in the sense of when it reduces whole foods. So for instance, animal fats are some of the few sources of vitamin K2 in the diet, and vitamin K2 has quite remarkable effects for bone health and osteoporosis. Egg yolks are some of the only sources of choline in the diet, or good sources of choline in the diet, and choline is very effective for preventing fat accumulation in the liver. In addition, humans are omnivores. We get a spectrum of micronutrients. Some are found well in plant foods, and some are found in good proportions in animal foods. And so perhaps if this advice to reduce our saturated fat ended up reducing whole animal foods, we might find ourselves with micronutrient imbalances and perhaps a lower quality of protein. But I'd like to finish off with an ancestral health perspective, because I've essentially debated whether or not polyunsaturated fat, reduces the risk of coronary heart disease by something like 13%, maybe 20%. And I think one thing we need to consider when talking about coronary heart disease and other chronic diseases is that these were almost completely absent in a number of populations. Modern day hunter-gatherers, the traditional cultures visited by Weston A. Price, dentists who travelled in the world earlier in the 1930s or so, 19th century Europe and Asia. So coronary heart disease basically wasn't a thing until the early to mid 20th century, and the blue zones. And these guys didn't all, focus on getting the latest superfood or nutrient demonization. Their diets were all based on whole minimally processed food with, large variety in, macronutrients and food intake. And also healthy lifestyle, exercise, sleeping in accordance with circadian rhythms, not having a high stress modern lifestyle. And the fact that coronary heart disease and other diseases is pretty absent in several populations is consistent with some evidence from observational studies that find that adherence to several lifestyle practices reduces the risk of coronary heart disease by 79%. And perhaps if they were to throw more criteria here, because they just used 5, sleep wasn't included, stress wasn't included, like something like dental health wasn't included, perhaps this number would start to go, 80 something, 90 something, who knows. But quite importantly, these behaviours were only present in 1% of the population. And why is that? There's obviously a lot of factors responsible for this, and several of the speakers have already touched on this. But I just want to perhaps give you one more idea, and that is that if people are receiving advice to reduce their intake of saturated fat, to take a statin, all that kind of thing, does that give themselves a false sense of security that, I'm lowering my cholesterol, is that all I can do? Therefore I'm just going to ignore everything else. Does it divert attention away from all the lifestyle behaviours that are really responsible for bringing that number down? Statins really only reduce the risk of coronary heart disease by 10 or 20% or something. And as you can see, lifestyle factors can do substantially more than that. So in summary, saturated fat and polyunsaturated fat are not associated with coronary heart disease in what I've called the adequately controlled trials. Mechanisms and risk factors, these things are both good to make hypotheses, but that should be tested in clinical trials. And when there is evidence from clinical trials, they should be used primarily. We eat foods rather than nutrients, and so dietary advice and policy should be based on food rather than nutrients. And finally, that chronic disease is not inevitable, but that multiple diet and lifestyle changes are necessary. And I recommend that you see the 10 healthy habits in your booklet. All right, thank you.